So far, our mixtures have been pretty straightforward. We've taken two or more ingredients and we've mixed them together. We haven't had to add any heat and we haven't had to change the temperature at all. But what if we did? What do you think would happen? Challenge number 3 turns up the heat for you Mixmasters, literally. In this challenge, we're going to look at the impact of temperature on mixtures and solutions, and to do it, we're going to dive into the particle model of mixtures. Ready? Zoom in. If we zoomed in on any type of matter, solid, liquid, or gas, we would see itty tiny little bitty particles that make them up. This is called the particle model of matter. There are 4 main ideas in the particle model. Number 1, all matter is made up of tiny particles. 2, particles of matter are always moving. 3, particles have spaces between them. And 4, adding heat to the matter makes the particles move faster. Now, scientists find the particle model useful for 2 reasons. First, it provides reasonable explanation for the behavior of matter. And second, it presents a very important idea that matter is always moving, that even if it seems perfectly motionless, it's not. The air you breathe, the books, your desk, even your body all consist of particles that are in constant motion. Look at a solid first. The particles in a solid are held together really strongly. The spaces between the particles are very small and it makes it really tight for them to move. Because of that, they're almost like they're vibrating instead of moving freely. But if you heat up a solid enough, the particles vibrate faster and faster until they have enough energy to break away from their fixed positions. When this happens, the particles can move more freely. They change from a solid to a liquid, and we call this melting. The reverse of melting is called freezing or solidification. This changes a liquid to a solid because the particles lose energy and move slower and slower. But let's not freeze there. In a liquid, particles are separated by the spaces that are large enough to allow the particles to slide past each other. Liquids take the shape of the container because the particles can move around more freely than they can in a solid. They're held together and they have a fixed volume. But let's turn the heat up even more. When a liquid absorbs heat energy, the particles move around even quicker. Some of the particles gain enough energy to break free of other particles. When this happens, liquid changes to a gas. This change from liquid to gas is called evaporation. The reverse process, the change from a gas to a liquid, is called condensation. As gas cools, the particles lose energy and they move slower and slower until it condenses back down into a liquid. Let's keep flowing. In a gas, the particles are separated by much larger spaces than in a liquid or in a solid. That means that gas is mostly empty space. A gas always fills up whatever container it's in. And since the particles are moving around constantly in all directions, they spread throughout the container no matter what the volume or shape of the container is. Let's look at an example before we move on to the challenge itself. Water. Pure water, or H2O. This time of year, we start to see it form outside in its solid form, ice. Water below the temperature of 0 degrees Celsius is found as ice. It's cold, it's hard, it's solid. You can pop an ice cube into a drink to cool it down, which leads us to our next phase, liquid. Water or liquid water, water above 0 degrees Celsius and below 100 is liquid. And get it past 100 degrees Celsius, it'll turn to steam. It will boil and turn it into the final form, which is as a gas. Challenge number 3, state switch. In this challenge, I want you to show me a mixture that changes states. Solid to liquid, liquid to gas, or the other way around. And so here's what to do. Make a mixture, and then change its state. Take, 100 milliliters of water with 35 grams of salt dissolved in it, for example, and either boil it or freeze it. Change the state. Make observations of what you see. Time how long it takes to change the state. In this challenge, there's a lot of things that you could do. Here's a few key points. Your mixture has to have 2 or more ingredients. You have to change its state. Solid to liquid, liquid to gas, gas to liquid, or liquid to solid. And you have to give detailed observations and a drawn diagram for each state. Track the temperature too, if you can. Now, you can also raise the stakes yourself. Instead of just doing one state change, try to do both. And if you want, you could also do a comparison experiment. Take pure water and your mixture and put them both in the freezer at the same time and compare them, or boil them at the same time and compare them. A big disclaimer though for this one. Temperature in the extremes, on either hot or cold, can be dangerous. Make sure that you have your learning mentor's supervision and permission to do this challenge. Are you ready? Let's get mixing.